Hello everyone, in this video we are gonna look at ionization of acids with water and dissociation of bases when they react with water. We're gonna use examples to explain this concept to you. So here I have the first example, hydrochloric acid reacting with water. Because it's an acid, hydrochloric acid, it's gonna ionize with water. What do we mean by ionize? It's gonna form ions, but those ions are gonna use water, okay? You remember when we define an acid, we say an acid is a proton donor. A proton is this hydrogen. It will donate the hydrogen. So it will donate the hydrogen to the water molecule and form hydronium ion. So you have 3 hydrogens with oxygen with a positive charge plus the chlorine ion. So it has ionized. It's forming a hydronium ion and chlorine ion. When this happens, it's called ionization of acid. Only acids ionize except for one base. So ammonia, I will show you that. Okay, now with our second example, we have ethanoic acid. The ethanoic acid is an acid from organic compounds. All the acids that are from organic compounds, they are weak acid. What do we mean by that? Weak acid, we say it ionizes incompletely. The first one, hydrochloric acid, it ionizes completely when we put it in water. What does it mean? It means you will not have hydrochloric acid anymore. You'll have hydronium ions and chlorine ions. Then if you have that kind of an acid, we say it's a strong acid. This one, it's a weak acid. When you look at my arrows, this one, I only wrote the arrow like that. This one, it shows that you still have some of that and some of that in your final equation. It will not ionize fully. Then this one is a weak acid. Okay, so because it's an acid, it's an ethanoic acid, it's gonna donate the hydrogen. Which one? Which hydrogen? You see here, you have 3 hydrogens that have bonded with carbon, and then you have this hydrogen that is from OH that has bonded with OH. So this is the hydrogen that will be donated, not these ones. So this hydrogen will be donated. So it will be donated to water to form hydronium ion, right? So you'll be left with CH3COO and the charge will be minus. Why is the charge minus? Hydrogen has a positive charge. So this whole molecule has a negative charge. When you put a hydrogen, it becomes neutral. That's why there's no charge there. So when you remove the hydrogen, you end up with a negative charge. Our next example is sulfuric acid, H2SO4. It reacts with water. It will ionize. We said sulfuric acid. So because it's an acid, it's going to ionize with water, forming hydronium H3O+. But now, look at the sulfuric acid. It has 2 hydrogen molecules. So those 2 hydrogen molecules are going to react with 2 molecules of water and form 2 hydronium ions. So here, you'll be left with only 2 minus. Now, why 2 minus? You remember you lost 2 hydrogens that were positive. So you had positive 2. If you lose positive 2 in the whole molecule, you'll be left with negative 2, right? So this one is the sulfate ion. The sulfate ion has a charge of 2 minus. Now, this reaction is not balanced. You lost 2 hydrogen to react with 2 water molecules. So you needed 2 there. And then to form 2 hydronium ions, you needed 2 there. This is how it's now balanced. It's very important to know that when you have an acid that has more than 1 hydrogen to donate, it will donate both of them. Let's look at another example. Okay, here is an acid. This is a phosphoric acid. It reacts with water. So what will it form? It's going to form hydronium ion and phosphate ion. Now it will be 3 minus. Why 3 minus? Do you see there are 3 hydrogens? So it's going to lose 3 hydrogen atoms. These 3 hydrogen atoms, it means they're going to react with 3 water molecules. So we'll have a 3 here. And they're going to form 3 hydronium ions. So we have a 3 there. So the phosphoric acid, it has 3 hydrogens. So it will lose all 3 hydrogens. When you look at this one, the phosphate ion doesn't have any hydrogen. So this is how acids ionizes. Whatever number of hydrogens they will lose, and then those hydrogens will react with water. That's why we say ionization. They will react with water to form ions, hydronium ions. That's why we say it's ionization of acid. Right, there's only one exception with bases. I've said all acid ionizes when they react with water except for one base. The base is ammonia. Ammonia, when it reacts with water, it also ionizes. But all the other bases, they don't ionize, they dissociate. So ammonia, NH3, will donate actually this is a base. This will be your acid. The water will donate the hydrogen to ammonia and form ammonium ion. So you'll have 4 hydrogens and a plus there. And then what will be left here? You'll have 1 less hydrogen. So you have hydronium ion, like that. This is the only base that ionizes. The rest of them, they dissociate. I will show you now dissociation of bases. Right, all base except for ammonia, they dissociate in water. What does that mean? When you pour a base in water, it will split into ions, but it will not react with the water molecule. So when you show it, you do it like this. The water molecule is written here like it's a catalyst. It does not react. When you look at ionization of acid, the hydrochloric acid reacted with water to form the hydronium ion and chlorine. It reacted with water. With bases, when they dissociate, they do not react with that water molecule. So what will happen here? This sodium hydroxide ion will split to sodium ion and hydroxide ion. It will not, the water will not be part of the product. So that's the main difference between ionization of acid and dissociation of base. Right, when potassium hydroxide dissociates in water, it will write the water molecule here. It will form potassium ions and hydroxide ions. Let's look at another example. Right, this one is calcium hydroxide. But now look at calcium hydroxide is different from the other two. The hydroxide ion is between the bracket and there's a 2 there. This 2, it's saying 2 molecules of hydroxide. Why do we need 2 molecules of hydroxide when it reacts with calcium? But when it reacted with potassium, we needed 1. When it reacted with sodium, we needed 1. It's on the periodic table. These 2 are in group 1. They have 1 electrons that they can donate. The calcium is in group 2. It has 2 electrons that it can donate, 2 positive charges. This one, you see, when you have a hydroxide, it has a negative 1. So a positive 1 and a negative 1, it makes the whole molecule neutral. Now, the calcium is in group 2. We need 2. We get 2 from calcium, 2 positive. So we need 2 negative from hydroxide. That's why you need 2 of them. I hope that explains it. Then when it ionizes in water, it will form calcium 2 plus hydroxide. But how many hydroxide molecules do I need? I need 2. So it will be balanced like that. Let's look at the last example. Right, magnesium hydroxide will dissociate in water to form magnesium ions, which will be 2 plus, and hydroxide ions. But you need 2. You'll get 2 hydroxide ions because of the 2. There were 2 of them. So when it dissociates, there are going to be 2 of them. So when it's balanced, it should be written like this. Okay, you really need to look at this video more than once, and it will help you with the rest of your chemistry, especially acid and base chemistry. This whole information, you need it with your further chemistry in acid and base. Thank you for watching. This is the end of our lesson.